Welcome to Tuesday Lunch and Learn. I'm James Shore. Every week we choose a software engineering topic, come up with a programming challenge related to that topic, and then solve it live on stream. And this week it's testing microservices with microservice clients without mocks. We're continuing what we did last week, and I'll get into that in just a moment. If you'd like to follow along with today's episode, you can find it on github.com/jamesshore/livestream. Check out this tag right here, 2020-09-01. Your comments and questions are welcome as always. Just toss them right here in the chat and I'll take some as we go. And there may be a little time at the end for more questions as well. We've got a really big episode today though. It is going to go a bit long, probably about 75 minutes or so. So I'm going to get right to it. If you remember from last time, we have a well-meaning but none too bright founders of our little company have been trying to make money by selling a Route 13 as a service. Route 13 is the little spoiler hiding mechanism. It's very, very simple form of encryption, sort of, if you can call it that, that converts an A to an M and so forth. You see it on the internet to hide spoilers. So they had us build a Route 13 as a service with the hopes that people would pay lots of money to Route 13 encode their stuff. But it turns out nobody did. So now their idea is, well, let's go back to building a command line application to do Route 13 for us. But now we're going to build it with microservice architecture. So everything's going to be better, right? Yeah, microservice architecture makes everything better. So last time what we did is we built the HTTP client we made a generic HTTP client that could talk to any server. We already had the command line. And so today we're going to build this specific Route 13 client that can talk to the server, and we're going to build the command line application on top of that. That's what we're going to work on today. And we're going to do this all in a way that can be tested without using mocks. Now, I've talked about this in the past. You can find past episodes down here, jamesshore.com/s/LNL for Lunch and Learn. But very briefly, and the specific episode you're going to look for there is called Testing Without Mocks. But very briefly, the reason we're doing this is that when you use mocks to test your code, although you can test that your specific module works in isolation, you cannot test that the modules it depends on work the way they think you do. And over time, those behaviors will change. And when they do change, your tests won't fail and your code will be broken and you won't know it. So instead of using these solitary tests, these mock-based tests that have gaps, we can use overlapping sociable tests. These are tests that actually call the dependencies, and thus when the dependencies behavior changes, our tests will fail. And that's a nice thing. If you don't have that, then you have to use extra integration tests, and that's slow, that's brittle, and it's duplicated effort. The net result is a nice linked chain of tests that makes sure that everything is tested without having to have a lot of integration tests. You can usually just get away with 1 or 2 smoke tests for your entire application, and that is really, really nice. So that is what we're going to do. We're going to build this Route 13 client application by finishing off the Route 13 client module, having it talk to the server, and then building the command line interface around that. And a really important part of what we're going to do today is we want the code to be robust. A lot of classroom exercises are focused on showing you how to do stuff, but they don't ever include error handling. But error handling is what makes the difference between code that falls over when things don't work right and code that just keeps on trucking. So we're going to do the actual error handling. So how do we do that? How do we get that difference between solid code and flaky code? And how do we do it in a way that's testable without mocks? I'll get to that in just a moment. First, though, I want to remind you all that this show is made possible by the people who hire me for training and consulting. If it wasn't for them, I would have to get a real job, and nobody wants that, especially not me. If I didn't have that support from the people who hire me for the training and consulting, I wouldn't have the time to do this for you now. What I do is people who have the capability for a lot of business agility, but not necessarily the technical capacity, bring me in to help teach their teams about how to work in a more agile manner from an engineering perspective. And also if they're experiencing bottlenecks between teams, they'll bring me in to help with process design and also to help resolve those bottlenecks, which tend to be both social, process, and technical in nature. If this is something that you think your company could benefit from, go ahead and send me an email, jshore@jamesshore.com, or visit me online, jamesshore.com. I also welcome tweets from anybody for any reason at jamesshore. Let me know what's on your mind. All right, let's get back to the challenge. We are going to finish our command line application and we're going to make it robust. How are we going to do this? Well, I've got 4 basic things we're going to do here. First, we're going to design the API for our Route 13 client. Now, we could have our Route 13 CLI, our command line application, we could have it use the generic HTTP client directly. And that is a tempting thing to do, especially for a small application like this. But it turns out that actually having the code talk to the server, there's a lot of things that can go wrong there. And that's where we come back to our error handling. And that's why I want it to be its own special module, so we can have all that error handling, all that complexity nicely isolated away. So we're going to use programming by intention to design the API of that Route 13 client. Programming by intention, of course, is writing your code as if everything that you wanted, everything that you needed to make it work already existed. Then we will use that API to build our Route 13 client, and we'll pay special attention to error handling using something called Paranoic Telemetry, and I'll get to that in a moment. Finally, we'll make that infrastructure wrapper nullable so we can be tested without mocks, and trackable as well. And then finally, we'll integrate it back to the command line code and be sure to handle errors and test that we're handling errors in our command line code. So that is what we're going to do. Like I said, we've got a lot of ground to cover today, so let's go ahead and get to it. Again, if you'd like to follow along, github.com/jamesshore/livestream. Check out this tag here, 2020-09-01. If you're watching this on YouTube, the finished code will be available under the tag 2020-09-01-end. Once you check out the code, you will need node.js in order to run it, but everything else is vendored in. You can use build.sh to lint and test the code, and that will look like this. You can also use, and it's build on Windows, you can use build.sh quick in order to only lint and test the things that have changed, and you can use watch quick to do the same thing, but automatically rerun the build when any files change. And that will also make a nice little sound for you when the tests pass or fail. Now, to run the code, first you're going to need to run the server, which you can do like this, /serve.sh, or just serve on Windows with the port. And then we can run it by passing the port and the text we want to transform. That's not implemented yet, so it just says to do. Okay, so that is what we're doing. Let's do it. All the source code, again, is on GitHub, and when you download that source code, what you're going to see is that we've got sort of a little mono repo here. There's the microservice code is in here, and again, that's all in the way that was implemented is all in the back episodes. You can find that again, jamesshore.com/s/LNL. The work was mostly done in the episodes called Microservices Without Mocks, parts 1 through 4. Then we have the command line application here. This is where we're going to be doing all of our work today. And then there are some shared libraries that are used by both here in the node modules. Not to be confused with this node modules, which has the third-party libraries that we use. There's not a lot of those. And the reason this is named node modules is just a little quirk of the way node.js works. So in our command line code, we've got Route 13 CLI. This is where this is almost the entry point. This is actually where things start. That just loads up that module and runs it. You can see that here what we do is we get our command line arguments. We do some very rudimentary checking on it because this isn't really about the command line processing. So I did a very simple thing there. And then we do the actual work. So this is where our programming by intention comes in. We're going to design the interface for our Route 13 client by using it as if it already existed, which it doesn't. So what we're going to want to do is we will take in our Route 13 client, pass it in. We can override it for the purposes of our test, or we'll default it to the real thing. We're going to want to say that we have one in our runtime type checking right here. And then once we have that, we can do something with it. And I think, I mean, the service really only has one endpoint, and that's the transform endpoint. So I think what we want to do is just say, hey, client, do the transform for me. That's going to be asynchronous. So we'll await it. And we'll pass in our port, and we'll pass in some text. Let's see, that's going to be asynchronous, so I'll put that in here. Now this is pseudocode. We don't actually have to be this precise about it, but I find it helpful to sort of think it through. And then we'll get a response back from that, and we will just write that response out to the command line. I think that's how it's going to work. We'll need the port, which will come from our command line arguments, and the text, which will come from our command line arguments. And I think that's all there is to it. So our API is really, really simple. We're just going to have a transform async, and that should do everything we need. So let's, this of course is not going to work because none of this stuff is in yet. So I'm just going to comment this out. And let's see. I do actually have a placeholder route 13 client file, so I'll go ahead and load that in so we can just stop these errors from happening. Okay, and now it's complaining that route13.create is not a function. So let's go ahead into our infrastructure code, and I will stub that in. Like that. And there we go. Okay, so here we are in our actual route 13 infrastructure code. We've got some tests and we've got the code, and obviously this is just all stubbed into place at the moment. So what we want to do is we want to implement this transform async. And the way we're going to do that is by calling the actual route 13 service. Now the route 13 service is documented in the README down here at the bottom under how the microservice works. You can see we have a URL, single endpoint, route13/transform. We post that URL with an application JSON header and a JSON object as our body. And when we do that, what we'll get is a 200 response back with the application JSON header, content type, and another JSON object which has transformed with the transformed result. So that's what we want our route 13 client to actually call and return back to us. So let's start out by saying that it makes the request. Now, if you saw the very first episode in this series, which again, you can find jamesshore.com/s/LNL, very first episode is called Incremental Test-Driven Development. If you saw that episode, you'll remember that I like to build my tests by doing something I call eating the onion from the inside out. That means starting with a sort of sweet, juicy core and then building out from there. So the very first thing to do is to define the interface, which we've done. And then I build out the happy path. And once that happy path is working, I'll take all the special cases and error handling conditions. So that's what I want to do here. I'm going to start out with this happy path, the simplest possible case of just making the request. So in order to make this request, we're going to need a route 13 client. So we'll make a route 13 client. And it's going to use the generic HTTP client we built last week to do its work. So I'm going to pass an HTTP client in as well. And that HTTP client is built as a nullable infrastructure wrapper. So I can create a null version of that HTTP client that works identically to a real one, except that it won't actually make any network requests. And this is nice for our test because now we don't have to set up a fake server or anything like that, and we don't have to use mocks. So I'll set up that null client, we'll make the route 13 client, and then we'll actually make the transform async request. And we'll pass in a port, and we'll pass in some text to transform. And what we want to do is we want to assert that this transform has actually made the request. And to do that, what we can do is take advantage of the fact that our HTTP client is trackable and has the ability to track requests. So once we tell it to start tracking requests, any request that is made is put into this HTTP requests array, and we can assert on that array. In fact, we can say that there's going to be one thing returned, one request made, and that request is going to be, well, everything that we have here. We're going to have a URL of route13/transform, and a method of post, headers with a content type header, a body that has a JSON object containing one field. So in this case, it would be text : text transform. And that's going to be JSON string, so we'll need to stringify it. So we'll pass in text to transform. And that looks like it. We've got our endpoint, method, headers, and body. Okay, so let's try that. Now it's going to say we don't have a transform async, so let's go ahead and build it. And now it should complain that we didn't make any requests. And that's exactly what happened. Our request tracker shows nothing. So that's good. Now let's go ahead and in our constructor, we're passing in an HTTP client. We're going to need that in order to make our request. So I'll save that off. And then we can say, go ahead and make the request. And that looks like it takes a whole bunch of stuff. So let's just run it and see what happens. Okay, so it says we need a host. So the host is going to be, I'm going to hard code it for localhost, and that's because I'm not trying to make this completely real. Normally you'd have it either come from an environment variable, or if this was on a server, you'd have some sort of configuration store or a command line application you might specify on the command line. But this is one area where I'm just going to keep this kind of a toy application. So I'm just going to hard code that to localhost. Okay, so we're passing in our host. The port we need to pass in. So we were going to put that here. Guess we'll need some text as well. Method was going to be post. Path was going to be our endpoint, which was route13transform. And now it's running, but we're complaining we're not getting our headers or our body. So let's go ahead and add those in. Our headers are going to be content type application JSON. And our body is going to be the stringified text. Okay, it looks like it's complaining. I don't think I put the host and port in the expectation, so let's go ahead and put that in. And there we go. Now we've tested that we are making the request, and the request is what we're expecting. So now we need to make sure that it deals with the response correctly. So let's go ahead and do that. We're going to say it parses the response. So once again, we're going to need to create the client, create the route13 client, etc. We don't need to track the request this time. We'll make the call to transform async, but this time the port doesn't matter because we're not going to be asserting on it, and the text doesn't matter as well. So I'm just going to make a couple of constants for that. And I do like to be really explicit in my tests about when something is not important to the test, because it makes the test easier to read for other people in the future. And by using sort of obviously wrong values, it also makes it easier if the values show up in a test assertion for you to figure out what's going on with those as well. Pellet says in the chat, I like the irrelevant prefix. I tend to use dummy, but I think irrelevant is more obvious with the intention. Yeah, I agree with that, Pellet. That's why I chose it. I used to just put in like foo or bar or just random junk, but I feel like using the word irrelevant just makes it super crystal clear to the reader what's going on. So we're going to transform, and then we'll get some sort of response back. Now, which response we get is not specified. So what we're going to have to do is we have to actually control our null HTTP client and say which response we get back. But fortunately, it's been programmed. And again, you can see that in last week's episode, jamesshore.com/s/LNL. We can control the response of the client by passing in an object with all the endpoints we care about. In this case, the endpoint we care about is route13/transform. And when we call that, we're going to expect this response back. And specifically, that's going to have a status of 200, a headers of content type application JSON, and a body of, again, it's going to be a stringified, transformed, and then my response. Or maybe transformed text. So if we do that, we can expect that the response should equal transformed text. But of course it's not, because we're not returning anything. So now we come into here and we're going to get our response from the client, and we can simply take our body, parse it from its JSON, and then return the transformed value. And that didn't work. And the reason it didn't work is not because of the test we just had, but because our request doesn't actually pass in any valid information. So we actually need to set up our HTTP client up here to have a valid request as well. And there we go. So that's it, right? We're done? Well, no, because everything that could possibly go wrong will go wrong eventually. The thing with third-party services, which is any service that your team does not directly control, is that they do change out from under you. The behavior will change, the API will change, and you won't necessarily get notified. I've had this happen to me many times with commercial third-party services that I pay for. They still change out from under me, and I don't always get informed. Sometimes it just shows up in my application logs. So it's really important that we do error handling. Now we could test. You'll notice that we're not testing against the actual service here. So it could be that we just got it wrong. And you could write tests that run against the actual service. But not only is that slow and brittle, it's also just not possible in some cases, like if you're talking to a service that doesn't have a good testing endpoint, or if it's doing credit card processing or something like that. But even if you did test against it, the fact is your tests don't run all the time, and the changes that the third party makes could happen at any time. So those tests, which are called contract tests, are not sufficient. It's not a bad idea, and especially if you're working with a team in your own company, you can actually write those contract tests and hand to them for them to run your contract tests for you. And that's a really cool way of operating, but it still doesn't protect you. You need your code to continue working, or at least fail gracefully, when, not if, that third-party service changes out from under you. Even if they don't change the API, things go wrong, it will fail. So you need your code to be robust against that. So this is really only the beginning. What we need to do now is the Paranoic Telemetry. So what we've done so far is we've used programming by intention to design our API. We've built the Route 13 client, but we haven't paid any attention to error handling. So that's what's next, that Paranoic Telemetry. And it's called Paranoic Telemetry because, well, they really are out to get us. Those services will fail at some point, and they will fail in production. Our tests cannot stop that. So we need our production code to make sure everything's working correctly. Now, before we get into that, I'm going to clean this code up a little bit. We've got some duplication here. So I'm going to take this code right here. I'm going to factor out the status. Actually, let's do it this way. Let's call this a constant, and we'll call it valid status. And this will be our valid headers. Pellet says it isn't paranoia if they really are after you, and those services, they are really out to get you. Maybe not intentionally, but they really will fail on you. If you're using them in any significant way for any amount of time, eventually they will fail. So I'm going to take this and I'm going to make a method that I'm going to call createClient. And that will give us our HTTP requests back and our Route 13 client. And I can take this and put it down here. And we can do the same thing here. Except now we don't need the request tracker. But I think to make this a little more clear, I actually want to pass the status through, just so the reader of this test, even though it's not strictly necessary, I want the reader to the test to see that we're passing through a valid status, headers, and body. And to do that, I'll need to take it here, status. Let's do it this way. Status equals valid status, headers equal valid headers, and body equals valid body. Pellet says the they here being somehow affiliated with the gnomes that steal single socks from the dryer. Yes, I'm not sure how single socks and network outages are related, but there has to be a connection somewhere. You know, if you read enough of the Discworld books, I'm sure the solution's in there somewhere. Pellet goes on to say that expect the answer will be in the appendix for the second edition for your book. Okay, so there's that just cleans up our test a little bit. So what all this is our happy path code. So I'm going to actually put this in its own block. And now I want to deal with the much bigger problem of all of our failure paths. And this is what separates classroom code from real production code, in my opinion, is whether or not you properly handle the failure paths. And even in production, I think there's still a lot of programmers out there who don't really pay attention to all the failures that can happen in their code. So, paranoic telemetry. The paranoic part says anything that can go wrong will go wrong. So now what we need to do is sorry, I just saw a comment from Third Man. I would probably pass in the transform text too. I'm not sure what you're speaking about there, Third Man. Could you maybe say a little bit more about that? So yeah, anything that can go wrong will go wrong. So when we look at our request or response, what are some of the things that can go wrong? Well, one of the things that comes to mind is that the status could be incorrect. So I think that's sort of the obvious first thing to do. So let's go ahead and do that. Let's say that it fails gracefully when the status code has an unexpected value. So we'll make our route 13 client. And we've got everything else defaulting to valid, which is a really nice way to work because then you don't have to specify everything every time. So we can just say that the status is, oh, let's say it's a 400. They don't like a request for some reason. Now what we're going to expect is we're going to expect this to throw an exception. We could have it log something, but I actually tend to prefer that my infrastructure code throw exceptions because the higher level application code is better situated to figure out how to log or otherwise respond to those exceptions. Third man says it's a bit disconnected between the test and the create client helper function. If you passed in, oh, I see what you're saying. Yeah, there's a disconnect here. So third man's basically saying for this parses response, there's a disconnect between transform text here and the transform text that's defined in our valid body. And you know what? When I first, set up what I was going to do today, that thought did occur to me. But the only way to really clean it up would be to make this a function, and I think that would be uglier than the way it is now. Right now, but this is part of why I wanted to pass in valid body here, so you could go find it. It's not ideal, but it's the best I got right now. I suppose you could say create client and pass in a body which was just transform text and have create client do the JSON stringify and everything else. The problem is with that is once we get into malformed bodies, that becomes much more complicated. So I think this is probably the cleanest way overall. It's my best guess anyway. You might have a better way of doing it. So we've created our client. Like I said, I want this to throw an exception because I expect the higher level application code to decide what to do with that exception. So I'm going to say that we're going to assert that this throws and that it's going to throw asynchronously. And this assert.throws async, this is not built into our assertion library, which is chai. It's something I had to build myself. If you're curious about how that works, you can find it in assert.js, which is a wrapper around chai. Pellet says it could be a matter of a constant for transform text. I kind of like that. Let's do that. Let's go with, so this is the valid transform text, I guess is what we'll say. Or valid body text, I guess. Yeah, nice cleanup. Thanks for bringing that up, Third Man and Pellet. Let's see, it's complaining about something. Valid body text is not defined. It's because I spelled it wrong. Okay, so back here, we're going to assert that we throw when we call route 13 client dot transform async. And we don't care about the port and text here. And we're going to get something back in terms of our error message. So we're expecting an exception, we're not getting one. So we'll say if response.status does not equal 200, then we will throw new error something. Okay, so that's working. Now we need to figure out the error message. And this is where the telemetry part of Paranoia Telemetry comes in. We could just say something along the lines of, what do I have in my notes here? We could say unexpected status from route 13 service. And that would be okay. But the thing is when this stuff goes wrong, it's probably leading to production failure, and it will go wrong at some point. So everybody's scrambling. You want your error messages to be absolutely as explicit as you can. So I will say something like unexpected status from route 13 service, but then I will go on and I will say a whole lot more. I'm going to say, what's the host we were using? Which in this case was host and the port. I guess the port isn't irrelevant. Port, let's say 999. But not only that, and there's going to be a line feed at the end of that. Not only that, we want to know what's the endpoint we were talking to. In this case, it's route13/transform. And what are all the ways it went wrong? Well, let's see what the status is. Status in this case should be 400. The headers should be, well, whatever the JSON stringification of our valid headers are. And the body as well. Just put everything out there so that you, in production, you can resolve these issues quickly. Let's see, this should have a plus. So now here's what our message is going to be. Unexpected status from route 13 service. Our host is localhost 999. Endpoint is this. Here's the status we got back. Here's the headers. Here's the body. That's everything we need in order to debug this problem. So now we don't have to go trawling through our logs. We can see it right there and solve it much more quickly. And this will save your bacon when things go wrong in production, which they will. So to do this, it's not that hard. We'll just make a multi-line string here. I'm going to say unexpected status from route 13 service. And then the host is going to be host and the port. Pellet says, a minor style question. Do you have a reason to prefer string \n plus string \n over the multi-line template or the string.join approach? No, I don't really have a strong preference. The thing with the multi-line templates is you get weird indentation from them, and so I tend to prefer not to do them, but obviously I've done it here. It's just, sometimes I'll do it one way, sometimes I'll do the other. I've never seen the use an array and then join it with a new line approach. That's clever, but I'm not sure if I like it, because I tend not to like clever code. I think I'd use the, although it would lead to some pretty nice code. Yeah, I don't know. I don't have a strong opinion about this one, to be honest. So let's get our endpoint. I'm just copying from our expectation here. Pellet says that they like the array with join because things line up nicely. Yeah, that does sound really nice. I might start trying that. Our status is going to be our responses status. Our headers are going to be the stringified version of our response headers. And our body is going to be the stringified, or it's just going to be our body, which has already been stringified by the server. And I think that will work. That should be response.body. And this should be host, like that. Okay, almost there. Looks like I've got an extra new line somewhere. Oh, this should not have a stringify on it. There we go. So there's our first failure case. But of course, this is paranoiac telemetry. Everything that can go wrong will go wrong. So what else could possibly go wrong? Well, if we look at just the things that we're setting up in our response, where do we have that? So we've got status, we've got the headers and the body. Now the headers are supposed to have a content type with an application JSON. And I'm a little torn on whether or not to assert on that. I generally don't check the content type header. And the reason for that is that if it changes, I don't want my code to fail. And it's not really relevant to anything I'm doing. Like, I'm going to assume that the body is a JSON. I'm going to try to parse it. If it doesn't parse, then I'll get a failure. So I have not yet started asserting on the content type. That is something you could do, but I'm going to ignore it. I'm going to say whatever content type we get is fine. Instead, I'm going to go straight to the body and say that we expect the body to be parsable. But before that, I think I'm going to say that it fails gracefully if body doesn't exist. So again, we're going to do something that's a lot like this, except now our body is going to be empty. In fact, before I do this, let's go ahead and factor this out into a single helper method to make this a little bit easier to deal with. I'm going to take this. I'm going to call it assert failure. And I'll pass through the status here. And this assert failure is going to take our, well, let's see, I think I'll do it a lot like, see, let me take this and copy it down to the bottom. I'm going to do this a lot like we have our create client because it's very similar code. So I'll take this, put it down there. We'll create the client and then we'll assert that we get a throw when we pass through all of our stuff. And this here is going to be status. This will be headers, and this will be body. Okay, still working, that's good. Now this becomes much easier to deal with. Now I can just say await assert failure, which I suppose should have an async on the end to follow my pattern. And that should now get a failure. Oh, I guess we'll need to put the message in there as well. So we'll need the message here, which will be, oh, let's go with body missing from route 13 service. Pellet says, do you find you need to test weird, rare fluke type errors like partial responses? Yeah, I do. I test everything. I even test timeouts, although we're not going to cover that today. So here we're getting an error, unexpected end of JSON input. So what we can do is come back into here, and let's take this and factor it out into a method. Call this throw error. Actually, take the whole thing and put it into a method. We'll need to send the message through, which in this case is going to be this. And that should still be working. But I need to pass it in here. There we go. So now that I've got that factored out, I can now do something really similar for the body. If body is equal to nothing, then we'll throw an error. And what did we expect? Body missing from route 13 service. Okay, what else could go wrong? Well, the body could be unparsable for some reason. For example, I've had cases happen where for some reason they started returning plain text to me rather than JSON because something had gone wrong somewhere. So we want to test that. So now our body is going to be just something random that's unparsable, and unparsable body from route 13 service. And I actually want to put in whatever that error message is, which in this case, I think we'll see it. Yeah, it's unexpected token X in JSON at position 0. So obviously we're not getting that, but we can get it. Now you may notice that these two are kind of redundant to each other, because if the body is missing, we'll also get an unparsable error. It'll say, we actually saw it up here somewhere. Unexpected, no, that's not it. Unexpected end of JSON input. But again, in production, when things are going wrong, you want to know exactly why. And it's just easier and faster to see body missing from route 13 service as opposed to unparsable body, unexpected end. Now, am I being a little bit overly generous in my error handling? Maybe, but I find that it's really helpful to be super explicit about your errors. Pellet says, do you have or know of a good list of oddities to test for? A lot of things I just know about because they've been bitten by them, but I think a list would be helpful. Yeah, the same thing's true for me, Pellet. I just know these things because I've run into them face first. But I do, as I go through this, I am looking at, well, what is everything that my code needs and is assuming? And I'll just test that every single one of those assumptions is true in my microservice clients. Pellet goes on to say, I've seen a lot of systems where a web server will provide response for certain classes of errors and would return errors formatted in HTML, even if the request was expecting to return JSON. Yeah, exactly. And then Pellet says, battle scar driven development. So true. So very true. So now what we've got is we're trying to deal with the fact that the body's unparsable. So I'm going to have to do a try catch because I don't know of any way in JavaScript to validate JSON without actually just trying to parse it. So we'll say parsed body, well, we'll basically do this, and then we'll catch the error. And if there is an error, we'll say, well, we'll throw an error, unparsable body from route 13 service, and then pass the JSON message through. Okay. And then finally, we could get a case where the JSON is valid, but the fields that we expect aren't present. So in this case, maybe the body says foo bar. Then I'll say unexpected status or unexpected body from route 13 service, and we'll pass through whatever the error message is in there. Here, we're not getting an exception. It's just returning undefined back to us. And it's really common for people to return undefined or null when they get an unexpected value, but that is not a good way of dealing with it, because what's going to happen is that null is going to get back into your business logic, and it's going to cause something to fail down the road with a null pointer exception or an undefined or something like that, but you won't know where it came from, and that is just not fun. So definitely check that your values are what you're expecting. In our case, what we can do is we can use the runtime type checking library, the same one that I use for checking my method signatures. That is called, it's used by the ensure library. It's called type. And this is something I wrote a long time ago. You can probably download something similar from NPM or whatever language you're using if you need. There may be some sort of type checking library for you there. I'm sure there is. So we can just say the type error is equal to type.check, and then we'll look at the parsed body, and we'll say that our response type, whatever that should be. And then if the type error is null or not null, then again, we'll throw the error. Something. And our response type, in this case, is we're expecting a transformed, which is going to be a string. Okay, it's complaining cannot read property status of undefined. That's probably because I did the throw error wrong. There we go. Should be unexpected body from route 13 service. And then we'll put in the type error, whatever that may be. Argument.transform must be a string but was undefined. That's pretty good, except I'd like it to say body.transformed. So I just know from having built this that we can add an option which is name body, and that will give us the name we're expecting. There. Body.transform must be a string, but it was undefined. Perfect. We can copy that into our expectation. There we go. Pellet says, presumably my favorite error was a really weird error that would occur when relying on a system that would parse JSON into Java classes based on types of fields. And if the type serializer couldn't handle something, you would get a crazy goofy error. Had to do something, had to end up doing the parse manually, handle things like ISO formatted date that was missing a leading up 0 on the date string. Yeah, I suspect similar situations are why you warn folks to strongly consider writing their own stuff instead of using a third party. Yeah, third-party code tends to be really, really bad. People think that it's good, but it tends to be overly complicated and under-tested. Now, I'm not saying you should build everything yourself. Part of the reason I build things myself in this series is just because I want to show you how it all works. I'm not saying you should build everything yourself, but I do find that a lot of the third-party stuff I use takes way too much time to figure out how to integrate because it's really more complicated than it needs to be. And then it doesn't work because it's doing too much complicated stuff, and you run into stuff like what Pellet's talking about, where the magic just breaks down when you deal with the real world you've got. Turns out that if you only are solving the problems you have in front of you, you don't have to build a big complicated generic library, and that code ends up being really small and simple, and sometimes it is cheaper to build it yourself rather than to deal with other people's bugs. And also those other people's code can sort of break out from under you when they upgrade, break something on you. So build or buy is not a question of do I spend time on this or do I get it for free? It's do I spend time on this myself or do I spend time on integrating and fixing other people's bugs? That's not as clear-cut of a decision as it seems. But, this is speaking with a lot of battle scars. Speaking of battle scar-driven development, I've run into a lot of crappy third-party code. Younger programmers or yet less experienced programmers think, oh, other people's code, I don't have to debug it. No, now you got to debug code you don't understand, and that's just not a fun place to be. Anyway, Rachel by the Bay had a Twitter rant about this recently that I thought was pretty well stated. I don't have the URL for it now, unfortunately. Okay, so now we're failing gracefully if the body doesn't have the value we expected, and I think this is everything. There's just one more thing I want to do here, which is that over time, services will add more responses to their responses, and we don't want, or add more fields to their responses, and we don't want our code to fail in that case. So we're going to say it doesn't fail when body has more fields than we expect. So in this case, I'm going to say that we're going to have a route 13 client. And we're going to pass in a body that's the stringified form of transformed response, and then we'll toss a foo bar in there. And we want to assert that this does not throw. And again, this does not throw async is something I wrote. You can find it in the util. Again, I am using the chai assert library, but I've got a little wrap around it so I can add the things that they're missing. Pellet says, now you get to debug it in the wild, presumably talking about the rant I just went into. Road 13 client dot transform async. And then again, irrelevant port and irrelevant text. So this shouldn't throw an exception, but it's going to, I think, because we are a little overspecified in our paranoia. Now we're saying that we have an unexpected parameter, which is foo, but we only want to check the things that we need to care about because we don't want it to break randomly when the code's not actually broken. So I'm just going to modify our options here to say that it allows extra keys. Like this. And there we go. So now that is our Road 13 client with the Paranoic Telemetry. We have the ability to call out to the service, parse the response, and deal with all the errors. I'm going to take this code here. I'm going to factor down to a method I'm going to call validate and parse response. That way we'll just take all of that complexity and tuck it away. So now our transform code reads really nicely. Here's the request we're making, and with the host, port, method, path, headers, and body, we validate and parse it, and then we return the parse response. And this validate and parse response, of course, could turn into a generic function. In fact, you can find a library that does this for you. And this is the kind of library where, setting aside the crappy library Pellet was dealing, this is the kind of library I probably would try to download because there's lots of little edge cases that that there can be. But on the other hand, it's not actually that hard to write, especially if you do it incrementally in the way that we've been doing here. So it's almost 1 o'clock my time. As I said before, we're going to go a bit long today. We've almost finished this, but we're not entirely done. We've probably got about 15 minutes left to finish this up entirely and hook it in to our command line interface. So I'm going to go ahead and do that. First, what I'm going to do though is I'm going to add our runtime type checking so that if this is used incorrectly, that it's a little easier to deal with. So the port and text should be a number and a string. And our create, let's go ahead and add that here as well. And I only put that on the public APIs. And of course, in a statically typed language, you don't have to do this. All right. So we've designed our API, we've built the Road 13 client. Now we need to make it nullable and trackable. And the reason we need to do this is so that it can be tested by our command line test. Our command line client, our command line code can test that it uses the Road 13 client correctly. So I'm going to add a new describe block here to the bottom. And this is going to be our nullability. And what we're going to want to be able to do here is we need to be able to control what the response is so that in our command line test we can say how the service responds without actually having to run the service. So it provides a default response. We'll make a null Road 13 client. Get the response from that. Uncle Scientist says, can't see my screen. Thank you. I apologize for that. Let's try that. So there's providing the default response, and then we'll assert that that equals, let's just say null route 13 client response. So route 13 client create null is not a function. So we need to create both of these, the create and the create null. They're just going to turn around and call the constructor, and they can pass through the appropriate HTTP client. For create, it's going to be HTTPClient.create, so to do the real thing. And for the null, it's going to be HTTPClient.create null. Now you may notice I'm not testing the create, and this is a little bit of a gap. I could test it against a fake server, but that would require spinning up a server, and that takes a lot of time out of our tests, and we've got a very small amount of code here that's very difficult to get wrong. So this is a case where I actually would use a smoke test, a simple end-to-end integration test, just to make sure everything hooks up end-to-end. I'm not going to write that today, though. For the create null, it's a bit more complicated, so I'm going to test that for real. So here we're calling create null, we're passing through a null HTTP client, but it's not working because by default, the HTTP client's response is a 503 response. And that, of course, can't be parsed. So what we need to do is we need to pass in a response, and we need to tell the HTTP client what its null response should be, which I'm just going to do by saying a route 13 transform endpoint should have an HTTP response. And that HTTP response is going to be status of 200, headers of content type application JSON, and a body of JSON.stringify. Well, let's just call it response. And that response is null route 13 client response. Let's see, and that needs to be an array. Okay, body must be an object containing at least transform string. Oh, right, this needs to be like that. There we go. By the way, there's our Paranoic Telemetry benefiting us already. We have such good telemetry that figuring out what I'd done wrong was really simple. It told us flat out that we needed an object, but we had a string. Okay, so this is a little weird, I'll admit, and this is perhaps a downside of using the nullable infrastructure wrapper as opposed to a mock, because it is requiring us to put our code to create the null into our production code, and some people don't like that. But it does mean that now when we use our route 13 client, we're actually wending our way through all of our real production code until we get to the part where we actually make the network call. So then we're actually validating that everything works end to end. So if the behavior ever changes for a route 13 client or HTTP client, our test will fail, and that's really valuable. So next we need to say that it can be configured. And that's going to be really similar code here. Except now I'm going to say that we're going to create it with a response of, let's just go with my response. Now I could set this up so that it was an array, but I don't think we've got we're not expecting a lot of cases where, or any cases where there's going to be multiple calls to the client. So I'm just going to make it simple for today. So this is going to fail because we're getting the null. That failed for a different reason. Oh, it wasn't expecting any responses, so our type checking failed. So yeah, let's go in here and say that our signature is expecting either an undefined or an object with a string response. And that string response can be undefined or a string. let's see, I want to see this fail. There it's failing with our null row 13 client response, but now I can pass it in. And we're going to want that to default to null row 13 client response. There we go. Now we're not entirely done here. We've made it nullable, but we haven't done everything we need to do, because we do need to also handle errors in our command line code, which means that our command line code needs to be able to specify that the row 13 client returns an error. So that's what we're going to do next. We're going to say that it can force an error. So we'll make a row 13 client, and we'll say that it has an error, which I'll just call my error. And then I'm going to assert that that throws when we call row 13 client.transform async. And that the error should have my error in it somewhere. I don't want to specify this whole complicated string again. So I'm just going to say that my error is going to show up in there. Okay, now we're getting an unexpected parameter, so we can pass that through here. We'll say that it can be either undefined or a string. And now we need to actually make it throw the exception. But that's pretty easy to do. We'll just say that our HTTP response, if the error is not undefined, then the HTTP response will be something that causes an error. Let's say status 500, headers we don't care about, and the body will be whatever error we've been provided. Otherwise, we'll do a valid response. And there we go. I think that is now all of our nullability for our row 13 client. Let me clean it up a little bit. All of this mess, I think we can factor out and call it null HTTP response. I'll take this and I'll put it down at the bottom. And that should still work. And then I think I can clean this up more by doing some early returns, which some people don't like, but I don't tend to mind. If your methods are short, I think early returns are fine. And then up here, I'll just inline that. No, I think I liked it better not inlined. Okay. There we go. The only thing we have left to do to finish up our row 13 client is to make it trackable, but luckily we have a library to handle that for us, so that will be really easy. Say it tracks requests. We'll create a client. We'll tell it to track requests. And then we'll assert that the requests are equal to something. I guess we'll have to make the request first. So we'll say row 13 client dot transform async. And let's say that what we get out of this is an object with a port and the text. That's going to fail because it's failing because we don't have an await. Now it's going to fail because we don't have a track requests. Now it's going to fail because track request is returning undefined. So to bring that in, I'm going to use the infrastructure helper that I built a while ago. And if you want to see how this works, it's in the archive under nullable output, or nullable output is where we build this request tracker, and then you can see us use it in testable logs. But that's actually very similar to what we're doing today. So our infrastructure helper is under util infrastructure helper, and it's going to use an event emitter. We're also going to need a request event. We'll make our event emitter. And then use our infrastructure helper to track it. So that should now give us an empty array because we're not emitting any events, because this is the way the tracker works is it listens for the events on the emitter. So we have to actually emit an event when we want to track something. So we'll just track the port and the text whenever we get a transform async call. And that should have worked, but I forgot the request event. There we go. Let's see. I think one more thing I'd like to clean up here is I want to take this piece here and instead put that down here like this, and our ensure as well, because that's where it tends to end up in the nullable code. Now we've got our type checking right next to the code that actually uses those variables. Okay, that's pretty clean, and I think we've now finished our Road 13 client. So we've built the Road 13 client. We've done paid a lot of attention to our error handling. We've made it nullable and trackable. Now we need to integrate it to our command line interface. I'm going to go ahead and check this in. Add Road 13 client. And now we get to get the fruits of our labors. As usual, when you're dealing with infrastructure, it's a decent amount of work. I mean, this wasn't a huge amount of work, but it's a decent amount of work to get your infrastructure wrappers working. But once they're working, you can just use them over and over and over again. And you end up spending much more time on your business and application logic and a lot less on your infrastructure. It's just for this series, I'm focusing on the infrastructure because that's the hard part. So it seems like it takes a lot more time than it actually does. So now that we have our client, we can come back to our Road 13 command line interface. Can bring up those tests. We can say that rather than being not implemented, we can say it calls the Road 13 service. To do that, it calls run async. That's going to create our command line. We can also have it create our Road 13 client. like that. We'll pass that through to our run async. And do we need to return it? I don't think we do. What we need to do is we need to return the route13 request tracker. So we're going to assert that when we run this, that we should get a request to our route13 client with the port 5000 and the text, my text. Because of course that's the arguments that we're passing in on the command line. But in fact we're not, and that's because we're not actually making the call. So we're passing the route13 client through here. We're getting the port and the text out of the arguments. Now we should be able to just call route13 client.transform, and that should work. But it didn't. And that's again because this is a sociable test. We're actually checking that this is working for real, and we're getting a type error. Our first argument should be a number, not a string. So that should be parseInt in decimal. There we go. Now we can assert that we get the response out on standard out. Of course, we need a way of providing that, which we can do. I'll just add it up here. When we run, we'll not just pass in the args, but we'll pass in the route13 response, which will be transform text. I'll get that down here. And then when we make our client, we will tell it that the response should be route13 response. And there we go. It's saying to do, but we expect to transform text. Should be fairly easy to just output the response. And that is working. It's just missing the carriage return here. So there we've got our happy path working. Last thing we need to do is handle errors. So let's go ahead and do that. It writes an error, or outputs an error, when route13 service fails. Do mostly the same thing, except we don't care about the requests, and we want standard error instead. Uncle Scientist, thanks for joining me. It should be done pretty soon, so yeah, there's just a couple minutes left for when you check the recording. I don't care about the response in this case, and I don't care about this, so I'm just going to assert that the standard error is equal to what? Well, the error is going to be this big complicated telemetry, and I actually don't want to specify that. So instead what I think I'll do is I'll say that the first line of the error should equal route13 service failed. And then the second line of the error is just going to match a regular expression, which I'll have it be my error. So what we'll do here is we'll specify that there will be a route13 error called my error. And we'll just pass that through down here when we set up a route13 client. Okay, currently it's throwing an exception, but we don't want it to do that. We want to catch that exception and handle it gracefully. So we'll put a try catch around it like this. And when we get that error, we will write standard error, something. What is it? Should be row 13 service failed. And then we'll write the error. And I think that will work. And it does. And with that, I think we're pretty much done. I'm just going to factor out this to be a constant called valid args. I suppose we could do the same thing that we did before, call this valid port, and this will be valid text. Oops, what did I do wrong? String to int says pellet, but I'm not seeing it. Oh, yeah. There we go. Thanks, pellet. Okay, I think that's everything. This session has gone really long, but I appreciate you all sticking with me. And I think we are done. We have now, we've designed our API, we've built the row 13 client, we've made it nullable and trackable, and we've integrated it to our command line code, making sure to handle errors. Now it should just work. So fingers crossed, let's see if it does. I'm gonna run the server over here, and then we'll run the code here, and we'll say, run against port 5000 with hello, and there we get our response back. It's working just fine. And if I don't have the server running and I run it, we should see it fail gracefully. And in fact, it does. Row 13 service failed, connection with a connect error. And if I were to somehow change the service, which I can do by going into the service here and modifying the router, the response, let's say if it's more than meets the eye, we'll and run that as a service. Now the API for our service has changed. We try to run it, and we get a failure. Unexpected body from row 13 service. Must be a string, but it was undefined. And here's everything that we need. So yeah, there you have it. Everything is working. I'm going to put this back. And I think that is all back to normal. Yeah, it is. Great. So I'll check this in. I'll have it in the tag 2020-09-01-end in just a few minutes. This has gone pretty long, so I don't think I'm going to take any additional questions, but I do have a couple of quick announcements for you. The next session is next week in the US is a holiday. It's Labor Day weekend, so there won't be a Lunch and Learn next week. So our next session is the following week, which is going to be September 15th. And that, I think, is going to be a really interesting one. We're going to continue building on this idea of everything that could go wrong will go wrong. And we're going to deal with what happens when the server picks up the connection and then just hangs. And that is a really common error. So how do we deal with network delays and timeouts? I also want to remind you that if you've liked what you saw today, I'm very happy to bring this to your company for a private session. When I do a private session, it's always using your language, your code, your libraries, the stuff that you need to work with, often working in your actual code base. That I work with Node.js on the back end, JavaScript on the front end, Java, and .NET. And if you're interested, go ahead and send me an email, jshore@jamesshore.com. That is it for today. Thanks very much. A quick reminder of what we did here. We have built a microservice client without mocks, really focusing on allowing us to build those sociable tests so that we could make it robust. We used programming by intention to design the API. We built the Route 13 client with a lot of attention to error handling using Paranoia Telemetry. We made it nullable and trackable, and then we integrated into the command line, making sure to handle errors there as well. Because again, handling errors is the difference between toy code and real production code. That's it for today. Thanks very much for watching. I'll see you all next time.